last class we started to talk about polygons, and today we're going to continue that. We're going to talk about polygons. Specifically, we're going to talk about their interior and their exterior angles. So that means what's true about the inside angles of polygons and what's true about the outside angles of polygons. All right, so just as a quick reminder from last class, a polygon is a two-dimensional shape that is closed, so that means that all of the endpoints meet, and the sides are segments. So that means that there's no curved edges. A circle, for example, is not a polygon. And we talked about that last class with some examples. All right, so quickly I'm going to name a couple of these. The names aren't terribly important, but you might want to write some of the names down. You might know a lot of the names already. All right, so depending on the number of sides, polygons have names. So if a polygon has 3 sides, we know it's called a triangle. If it has 4 sides, this is what we just studied last in this unit. It's called a quadrilateral. And then they start to get some new names, but you might not know some of these as well. If they have 5 sides, it's called a pentagon. 6 sides is a hexagon. 7 is a heptagon. 8 is always easy. It's an octagon, easy to remember. And I'm going to go up to 10 just because these are like the most common names. So 9 is a nonagon and 10 is a decagon. And then after 10, some of these do have names, but you certainly don't need to know these names and they won't come up very often. So after 10 sides, we're just going to start calling them by whatever number of sides. So like 11, we'll call that an 11gon. Okay, so 12 is a 12gon, 13 is a 13gon, ... If I went all the way up to n can be any number, I would just call that an n-gon. So that's just like a generic name for any polygon. You don't really have to have these names memorized, but especially I would say like the first, really any of these top 10, you might see that vocabulary in a problem. So it might say, what's the measure of a heptagon? So it would be helpful to have them written down, or I guess you could always just Google it to remind yourself if you forget how many sides that shape has. But again, anything after 10, we'll call it by whatever number sides it has. All right, so that's the stuff that, just the basics of polygons. Now we're going to talk about the interior angles of a polygon. The interior angles of a polygon. Again, interior meaning inside. The angles inside a polygon. And we started to talk about this last class. We investigated and we did it by drawing triangles inside of a polygon. And we actually came to this formula last class. We said for any polygon with n sides, so n can be any number, I'm going to write the formula and then we'll talk about it. S is going to stand for sum, so the sum of the interior angles is 180 multiplied by whatever n is, subtract 2. So this stands for the sum of the interior angles, so the sum of all of the angles inside of a shape is 180 multiplied by n, so that's the number of sides, subtract 2. All right, so we'll do a couple examples using this formula. It's pretty straightforward. All right, So I'm going to say, actually, I'm going to delete that. I'm going to say, what is the interior angle sum of a 21 gon? Okay, so that is, what is the interior angle sum of a shape that has 21 sides, a polygon that has 21 sides? And so to do that, we're just going to apply this formula, right? So the sum of the interior angles is equal to 180 multiplied by 21, that is our n, right? So I'm going to put that right here. 21 minus 2. And so I get 180 multiplied by 19. And you can use a calculator obviously to help you with that. That is 3,420 degrees. So again, the only thing that you really have to do to apply this formula is figure out what is n, and that gets plugged into your formula. And you might be able to do that in your head. That first step, you're like, okay, 21 minus 2 is 19. I just multiply 19 by 180. So that's how you apply the formula. So this formula should definitely be written down on a reference sheet, on a note sheet, somewhere that's easy to access. All right, let's do another example where we apply this formula. This time I'm going to apply the formula in reverse. So I'm going to say a polygon has an interior angle sum of 1,440 degrees. How many sides does it have? So the big difference is that if I try to apply the formula, right, in the previous problem we highlighted n. N is the number of sides, and we knew what n was. In this case, I don't know what n is, right? How many sides? So I'm going to highlight where it says how many sides. I don't know what n is. So I'm going to write, that means that n is question mark. I don't know what that is. So I'm going to set up my formula. The sum of the interior angles is equal to 180 times n minus 2. I don't know what n is, so I can't plug a number in there. I do not plug in 1,440 in for n. What I do know is that the sum of the interior angles is 1,440. I'm told what the sum is. So I can take my 1,440 and plug it in for the sum, set that equal to 180 times n minus 2, and now I'm going to solve for n. There are multiple algebraic ways that you could solve for n. The easiest way is to work backwards by dividing by 180 first. That will cancel a 180 degrees on the right side of your equation. And when you divide by 180, you should get 8 on the left side of your equation. And on the right, we just have n minus 2. And the last step is just to remember that we're solving for n, so we have to add 2 to both sides. And we get that n is equal to 10. So remember, let's make sure we answer our question. How many sides does it have? I'm going to write n sides. Oops, I don't know why I just wrote n sides. Hold on. I'm going to write 10 sides. It has 10 sides. Okay, the last thing we're going to talk about is how to find exterior angles. So exterior angles of a polygon. And this formula is actually really nice and easy. So the exterior angles of a polygon. So if I were to take a polygon. So I'm going to draw a polygon we're really familiar with. I'm going to draw a triangle. And I'm actually we know that a triangle totals 180 because we're very familiar with this, but let's say that this triangle, I don't know, this is 80 degrees. Let's say this is also 80 degrees. 80 and 80 is 160, so this is 20 degrees left over. So I just made up some angles to make this work. Those angles I just labeled are interior angles, right? Every shape, every polygon has interior angles, and it also has exterior angles. So I'm going to write here that each interior angle has a supplementary, we know what that word means, exterior angle. And I'll show you what I mean. So if I pick an interior angle like 80, I'll pick this 80 on the bottom right here. If I extend this side like that, I have now an exterior angle. And that exterior angle is supplementary with 80. So let's label that exterior angle. That exterior angle, if it's supplementary, would have to be 100 degrees. So I could mark it like that. All right, so let's pick another one. Let's pick 80 over here, and I can extend this way, right, to create my exterior angle right here. Or you can extend this way, it doesn't matter. Either way, you'll notice that my exterior angle is supplementary with 80, it's 100 degrees. So there I have two. And then lastly, let's go up to our 20, and I'm going to extend in either direction. So I'm going to extend this way, and I will create an exterior angle. So there's my exterior angle, and my exterior angle has to be supplementary with 20. So 180 minus 20, this has to be 160 degrees. So each of my interior angles has a supplementary exterior angle. And what's cool about exterior angles, it's actually very easy, the formula, because if you look at these three angles, 160, 100, and 100, and I add them up, I get 360 degrees. And that's not a coincidence, it's actually what you will always get for the sum of the exterior angles. So I'm going to write for any polygon, the sum of the exterior angles is 360 degrees. And I'm going to write that as a formula. S for sum of the exterior angles is 360 degrees. No matter what the polygon is, it is always the same. Okay? So I could do a really quick example. What's the sum of the exterior angles of a 48gon? And you really don't have to think too hard about the example about the number of sides here, because it doesn't matter. This is for any polygon. Your answer is 360 degrees, no matter what. All right, so I want you to use these notes. You have two formulas, right? Our two formulas are this one, which is pretty straightforward. It's always 360. And this one. And you should use those two formulas to do the practice problems and the exit ticket for today.